Okay, so today we're going to be looking at lesson 8-5, angles of elevation and depression. So open to this page in your packet. It is the last lesson in the chapter 8 packet. So just open here and then follow along in your own packet. We're looking at these two terms, specifically angles of elevation and depression, and these are like trigonometry word problems. We're going to be using trigonometry to either solve for angles or the length in a right triangle. So first of all, angle of elevation is a line of sight upward and a horizontal line. So looking at the picture here, we have this person. We have the line of sight upward to a point and then a horizontal line. So this forms that angle of elevation. I'm going to highlight the angles of elevation in pink. Okay. And then if you look even more closely, you do have a right triangle here, and this is where trigonometry comes into play. The angle of elevation is always inside the triangle. So here it is right here, the angle of elevation. Then we have angle of depression. Angle of depression is a line of sight downward. In the picture, the line of sight downward and a horizontal line. So in the picture we have an owl looking down at a squirrel, it looks like. And that and the horizontal line from the owl makes the angle of depression. We're going to use yellow for angle of depression. If you don't have a highlighter, that is okay. Okay, now looking at the next example, it says name the angle of elevation and depression in each figure. So here we have a sailboat. Remember, angle of elevation is the line of sight upward and the horizontal line. So this is our angle of elevation, and it looks like that is angle RZY. And we will label that with an E for angle of elevation. Then for depression, it's the line of sight downward. So if you're up at this cliff or hill, the line of sight downward and a horizontal line, and this would be angle TRZ. Okay, the next picture here, it shows a hot air balloon and a person. From the person, the line of sight upward to the hot air balloon along with a horizontal line makes that angle of elevation, so that would be angle ZPR. And then the angle of depression is a line of sight downward. So if you're on this hot air balloon looking down at the person, there's your line of sight downward along with the horizontal line. So here's depression, elevation, angle of depression, and naming this angle WZP. Another thing that is important to note is the angle of elevation is always equal to the angle of depression. If you look closely, you have two horizontal lines, which would be parallel, and then a transversal here. And alternate interior angles are congruent, so therefore the angle of depression and the angle of elevation is the same measure. Okay, now we're going to look at some examples. For the first two examples, they give us a picture, which is nice, but for the examples on the other side, we're going to be drawing our own pictures. The first example says an air traffic controller is looking at an airplane 5,000 feet away at an angle of elevation of 32 degrees. How high above the control tower is the airplane? Okay, so again, they do give us a picture. We're looking for this length here, and it shows that as x. We're going to be using trigonometry, so go ahead and write SOHCAHTOA on your paper so you can reference it. We have our angle, opposite side, and adjacent, so therefore we are going to use tangent. So setting up the problem, tan of 32 equals x over 5,000, opposite over adjacent. Then from here, solve it by multiplying both sides by 5,000. And the problem we're going to type in the calculator is like this. So in the calculator, it would be 32 tan times 5,000. And we get this number is 3,124. So x equals 3,124. And for these problems, I'm going to round to 2 decimal places, so 0.35 feet. Okay, next example. Now we're going to be looking at an angle of depression, so keep that in mind. It says an alien standing on top of a 40-foot tower, here's our tower, spots a fire on the ground at an angle of depression of 28 degrees. He wants to call the fire department, but first he needs to find out how far the fire is from the base of the tower. Help him find the distance. Okay, again, they do give us a picture, and notice the angle of depression, line of sight downwards, and a horizontal line. So the angle of depression is actually up here. From this angle, you have opposite and adjacent. So again, we are going to be using tangent, and you'll find you use tangent a lot for these problems. Tan of 28 degrees is 40 over x. Because it's OA, I need to make sure to do opposite over adjacent. Now this problem has a variable as a denominator, so I need to take a few more steps to get it ready to go in the calculator. Multiply both sides by x. Okay, and then I have this problem here, 40 divided by tan of 28. In the examples in the homework, I told you to find 28 tan, which is the decimal, and write that decimal down, then do 40 divided by that. But somebody showed me a trick in this calculator where you can actually just type it in as is, 40 divided by 28 tan, you get tan of 28, and then if you hit equal again, it actually divides it for you. And that is our answer. So x equals 75.23 feet. That is the distance from the alien to the fire on the ground. So it's this distance here. And notice there is two triangles here you could work with. This angle of depression, remember, is the same as the angle of elevation. So this is also 28 degrees. This is also 40 feet, the height of the tower. So if you wanted to draw that angle, that triangle the other direction, it would work the same exact way. Okay, now on to the next page. Okay, so for these examples, we're just going to look at different scenarios. Again, for these, we do not have a picture, so we actually have to draw the picture ourselves. Okay, so the first one says the angle of elevation from point A. So I'm going to draw point A down here. Remember, angle of elevation is going to go up, so if I draw it down here, my angle of elevation will go upwards to the top of a hill. I'm going to draw that hill here, and it says this angle of elevation is 49 degrees. If point A is 400 feet from the base, so this is 400 feet, find the height of the hill. So here's our right triangle. We're going to look for this height here. Okay, so let me write down SOHCAHTOA because, again, we're going to use that throughout this page. From this angle, we have opposite and adjacent. So, again, we are going to use tangent. Tan of 49 degrees is x over 400 feet. Now to solve this, I'm going to multiply both sides by 400. And then I can plug this into the calculator. With this calculator, I'll do 49 tan times 400. And I get my length, 460 feet. 0.15 feet. Again, I'm just going to round to the nearest hundredth place each time. Okay, the next example. Find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. This setup is different. It took me a minute to kind of figure out what they were talking about. So we have our sun, we have our 12 meter long telephone pole, and then the 18-foot shadow. Okay, so we have our sun, and it's going to be shining down this way. And it hits the telephone pole, makes the shadow. Angle of elevation falls right here, so it wants to know this angle. Okay, so based on that angle, we have opposite and adjacent again. So we're going to use tangent. Tan of x, this time we're solving for the angle, is 12.5 over 18. Okay, when I plug this in the calculator, I need to do 12.5 divided by 18. And then I'm going to use inverse tangent, so second tan. And I get 34.78. X equals 34.78 degrees. And that's the angle of elevation. And again, angle of elevation, horizontal line, and viewpoint upwards. Number 5. Now they're going to switch to angle of depression. And it'll be a little bit different, as you'll see. A ski run is 1,000 yards long. So drawing my ski run, and it's 1,000 yards. With a vertical drop of 208 yards. So the vertical drop over that 1,000 yards is 208 yards. Find the angle of depression from the top of the ski run to the bottom. So angle of depression is a line of sight downwards and a horizontal line. So the angle of depression is actually right here. So we're going to solve for this angle. From this angle, we have opposite and hypotenuse. So now we're going to use sine. Sine of x, we're solving for the angle, is opposite over hypotenuse, so 208 over 1,000. In the calculator, just do 208 divided by 1,000, and then second sine, 12.01. Okay, the next example. Okay, now we have a 120-foot high tower. Drawing the tower. An air traffic controller, so he's sitting at the top of the tower, observes an airplane on the runway at an angle of depression of 19 degrees. So here is our airplane. I don't know if I can draw an airplane very well. That wasn't too bad. He sees an airplane, and the angle of depression is 19 degrees. So his line of sight downwards and the horizontal line make a 19-degree angle. How far from the base of the tower is the airplane? So we're actually trying to find this length, right? This would be our x. There's two ways you could do this. You could, since angle of elevation and depression are the same, you could fill in 19 degrees here. You could also draw the triangle here and know that you're solving for this x here. So we're actually just going to focus on this triangle. And again, if you wanted to put down 19 there, that would be fine as well. We're going to just focus on this one. We're going to find this distance. This would be the distance to the airplane. And then if the height of the tower is 120 feet, this is 120 feet as well. So based on this angle, we have opposite and adjacent. So we're going to use tan. Tangent of 19 equals 120 over x. Okay, now we need to solve. Multiply both sides by x. And then divide both sides by tan of 19. Okay, so I'm going to use that trick that I think it was Kendall showed me this trick, Kendall Crowell. We are going to divide this here. So 120 divided by 19 tan, and then if you hit the equal sign again, it gives you the answer. So it's 348 yards. X equals 348.51 yards from the tower. Did that come out right? I hope it did. Yes. Okay, I'm just checking my work here. Make sure it came out right. 120 divided by 19 tan. Yep, 348.51 feet. Oh, I'm using yards. The last one was yards. This one's feet. Okay, next example. A fire ranger on a 150-foot tall tower, so another tower, 150 feet tall, spots a fire at a 30-degree angle of depression. So here he is at the top of the tower. Here's the fire. I don't know how to draw fire. There. Okay. 30-degree angle of depression, so line of sight downwards and the horizontal line creates a 30-degree angle of depression. How many feet away from the base of the the tower is the fire. So I'm going to draw my triangle here. We're going to find this distance, the length from the tower to the fire, and then the height is 150 feet here. So based on this angle, opposite and adjacent, going to use tangent again. Tan of 30 is 150 over x. Multiply both sides by x. And then divide both sides by tan of 30. $150 divided by 30 tan. Hit the equal sign again, 259. So x equals 259.81 feet. Okay, and the last example. A person is standing 40 feet from a flagpole. Drawing the flagpole. There's our flag. And can see the top of the pole at a 35-degree angle. So here's our person. 40 feet. I need longer legs on this person. Okay. 40 feet from the flagpole. Can see the top of the pole at a 35-degree angle of elevation. So that's our line of sight upwards, and a horizontal line makes a 35-degree angle. The person's eye level is 4 feet from the ground. So this person is 4 feet here from the ground to the eye level. What is the height of the flagpole to the nearest foot? Okay, what do we have? If this here from the feet to the eye level is 4 feet, then this here is 4 feet as well. And then if this distance from the foot to the flagpole is 40 feet, then obviously this is 40 feet here. Now we need to find this length. And then once we find that length, we can add it to the 4 feet to find the entire height of the flagpole. So from this angle, we have opposite and adjacent. So tan of 35 equals x over 40. We're going to solve for x and then add that number to 4. So multiply both sides by 40. 40 tan 35 equals x. Plug it in. 35 tan times 40, and I get 28.01. Okay, we can take that. That's this length here. So this is 28.01. 28.01 plus 4 feet equals 32.01 feet. And that is the height of the flagpole. Okay, so that is all for this lesson. At this point, make sure that your entire packet is complete and turn it into the sub, and then finish your weekly Khan Academy if you still have some Khan Academies left to complete. Have a good weekend, and I will see you on Monday.